It's an important skill for a chemist to be able to look at a chemical formula like H2O or C2H5OH or C6H12O6, then be able to figure out what that is made of, what elements are involved, how many atoms of each element, and how those atoms stick to each other or bond to each other. To get to that point, we need a little bit of practice with some simpler classification first. We can't just jump straight into the deep end. So before we get into talking about how things bond and why things bond, the way we name stuff, the nomenclature, the terminology, we've got to start at some of the basics. So in chemistry, we think of matter as atoms, okay? We usually symbolically show atoms as either circles on a drawing, or we use spheres in models, physical things that you can grab. Okay, atoms are the smallest bit of matter that keep that characteristic of an element that has certain properties. Okay, so it's not the smallest bit of matter, period. Okay, but it's about as small as we can go before you start to lose the characteristics of elements. Okay, well, what are elements? Elements are essentially just a type of atom. Okay, so we can have atoms of hydrogen or atoms of helium. We can have atoms of carbon, iron, nickel, gold, silver, fluorine, chlorine, bromine, all kinds of stuff. Whatever you find on the periodic table, you can have an atom of that element. Okay, so when we symbolize these as drawings or as models, okay, again, usually a circular sphere is an atom, and the color usually represents an element. Okay, there are some characteristic colors that we try and match up with specific elements, like, for instance, red tends to be oxygen, white tends to be hydrogen, okay, black tends to be carbon, and things like that. It doesn't necessarily have to be that way, though, and it's not how we're going to kind of treat things at first. All we have to do is recognize that different colors mean different elements. Now, does that mean that elements are these specific colors? No. By the time you get down to the nitty-gritty of atoms, color doesn't mean a whole lot. Okay, it means something to us, at the level we see, but down on the level of atoms, not really. Okay, it's just a quick and convenient way to be able to tell one element from another when you're looking at atoms as they stick together or sit next to each other. Okay, so matter is made up of atoms, okay, in chemistry, and some smaller stuff that we'll get into later. Okay, atoms can be made into pure substances, okay, in a couple different ways. There are a couple ways we categorize pure substances. Okay, either we can have an element, okay, off the screen there, okay, or a compound, okay, and if we're dealing with an element, we can kind of go one of two ways also. Okay, so an element is what it is. It's an element off the periodic table, but it can come in two different forms. Okay, we can either have an element that is just one atom of that one element, or we can have two atoms of the same element stuck, bonded together. Okay, a monatomic element might look something like these little drawings here, or it could be something like this. Okay, it could be an example of a monatomic element, or like this. Okay, one atom, one element, one color. Okay. Now, rolled off the table. Okay, a diatomic element is two atoms of the same element. Okay, so something like this. Okay, or something like this. Okay, two atoms, two spheres, two circles. Okay, same color, which means the same element. There's another one. Diatomic element, and one more, something like that. Okay. So elements can only have one element, which kind of in the name. Okay. Compounds, though, have to be a combination of at least two different elements. Okay. So, for instance, water is a common compound. Okay, this is a model that could represent water. All that matters to make something a compound is you have two different elements that are stuck together, they're bonded together. Okay, And in a lot of cases, if you look at something like this, okay, we can just tell easily by looking at the different colors, okay? Different colors touching means different elements that are bonded together, okay? That automatically makes a compound, all right? This is another compound, okay? Looks very similar to the last one, but different colors, different elements, okay? This is also a compound, okay? This in total has like 1, 2, 3, 4, 5 atoms, okay? So there's no specific rule on how many atoms a compound can have. It can have basically as many as we can fit, as many as we can bond together. All right. We can also have more than just 2 elements, okay? This is a compound that has 3 different elements and a total of 4 atoms, okay? So there's all kinds of different combinations we can make to put atoms together into compounds, okay? But all that makes it a compound, the only thing that needs to happen to make it a compound is it's got to have at least 2 different elements, okay? 2 different colors shown of atoms, all right? This is one that trips a lot of people up. Let's say we have something like this. Okay, well, it's 2 atoms. So you might jump to it and say 2 atoms, that's diatomic. Di means 2, okay? And yes, there are 2 atoms, but a diatomic element needs to be made of just 1 element, and this has 2 different elements, okay? So even though it's 2 atoms, it's automatically a compound because it's got 2 different elements in there, 2 different colors of atoms in here in this model, okay? So that's one you got to be careful of, okay? So monatomic elements, diatomic elements, and compounds are different kinds of pure substances. If you go deeper into chemistry, you might be a little more specific about some other things, but that's the basics. That will cover most of the things that we deal with in chemistry. Okay? 1 atom of 1 element, mono is 1. Okay? Di is 2, so 2 atoms of the same element. And then a compound is a combination of different elements. Okay. Now, we can also take pure substances and start to mix them together into mixtures. Okay, so if we have more than one pure substance, like one of these guys and one of these guys floating around together, we can make a mixture. Okay, typically we need more than just 2, pieces of a pure substance to kind of put next to each other to make a mixture, because we like to categorize them as either a heterogeneous mixture or a homogeneous mixture. Okay, to best figure these out, we need to see a lot of these. Now, the way that we kind of pick these 2 apart a lot of times is based on what you can see with your eyes. So I'm going to grab an example here. This is an example of a heterogeneous mixture. Okay, if you look here, you can see all these different minerals that make this thing up. Okay, you can tell just by the different colors you see on here. Okay, so just at a glance, you can tell that this is made of a couple different things. Okay, a couple different pure substances make up this mixture. Okay, that is a heterogeneous mixture. You can tell the different pieces apart just by looking at it. Okay, but it's not always so simple. Okay. Let me get this bottle of hand sanitizer. Okay, this is just a clear liquid on the inside. If you go and read the ingredients, okay, we've got ethanol in there. We've got water. We've got carbomer. We've got, ooh, that's a hard one to pronounce, triethanolamine. Okay. But if I look at this, I can't look at them and be like, ah, yeah, I see the triethanolamine. It all looks like one substance. It all looks like a pure substance. That's a homogeneous mixture. Okay? If you can't tell it's a mixture just by looking at it, that's homogeneous. Now, thankfully, we can tell it's a mixture if we look at the atomic level, if we get down to the nitty-gritty of how atoms kind of sit next to each other. Okay? So, when we go look at something like that, we can tell a heterogeneous mixture and a homogeneous mixture apart based on how the pure substances sit next to each other. Okay? So, for instance, a heterogeneous mixture has kind of clumps. It has sections of the pure substance that sit away from the other pure substance. Okay? Whereas homogeneous mixtures are all scrambled up. Everything sits near each other. Okay? They all kind of mix in together. Okay? So, From the atomic level, we basically look at these two as how these different substances commingle with each other. If they're in kind of the same room, but they won't kind of get in with each other and be friends, then that's heterogeneous. Okay? If they'll go in between each other and they'll kind of all it does is make a repeating pattern, that's a homogeneous mixture. Okay? And that's the basics. Okay? So a pure substance could either be an element or a compound. And then we've also got mixtures that can be heterogeneous or homogeneous.